Good afternoon, everyone. Welcome to the AWS Networking State of the Union talk. I'm Dave Brown. Some background on myself. I've been at Amazon for just over 10 years now. I've worked on a number of things. I started off on the EC2 team in Cape Town, South Africa, back in the day, and pretty much been on EC2 the whole time. Today, I own everything network related, so everything from elastic load balancing through to the VPC, through to VPN, and a number of other networking services. So we've got a lot to cover today, so I hope you're ready as we dive in. So to start off, one of the things I really enjoy about working at Amazon, and this has really been true for all my time at Amazon, is just how much time we get to engage with customers. And it's super impressive to look at a slide like this if you just look at the number of verticals that we have customers in. And it's really great, at reInvent, meeting with all of you and discussing features. I spent most of my time at reInvent in EBCs, meeting with customers. And just great getting that feedback. And so thank you very much for all your business and the time that you spend giving us features, our feature requests. So, to start off with, I thought we'd look back. 2012 was the first reInvent. We thought it was absolutely enormous. 6,000 people. AWS employees, we were just surprised that there were so many people using our cloud and all came to this conference. Any of you were at the first reInvent in 2012? Great to see some hands. Any of you been to this would be the 6th reInvent? Great, good to see a few of you. I'm also one of the privileged few that's managed to do that. This year we're at 42,300 and something. So it's a pretty crazy attendance. The other thing is 5 years ago, what did the AWS network look like? And we had a couple of services. Amazon VPC had been launched in 2009 without internet access. You had to use a VPN connection to use VPC back then. In 2012, all new accounts were still running on EC2 Classic, and VPC was just really starting to become something that customers were beginning to use in earnest. The Elastic Load Balancing service had a single load balancer, which we just called Elastic Load Balancing. We didn't need to call it anything else. Now we call it the Classic Load Balancer. Classic is a nice word for the first one. Today, if you move on, you can see just how this picture's changed. VPC's got a number of new features, things such as flow logs, elastic network adapters, a number of other things there. ELB is a completely new service. We have the application load balancer for layer 7 HTTP type workloads, and we have the network load balancer for TCP or layer 4 type workloads. And this is our first reInvent on the ELB side where we really have both of our planned load balancers in place with a lot of features on, and we're really just iterating and building on that. So it's been really exciting to come to reInvent this year with those load balancers in place. The other thing is we've got a couple of green services there, mostly in the security space. Those services have been launched over the last 2 years, things like Certificate Manager, AWS WAF, and AWS Shield. So they're also part of the networking space. So the structure of the talk, if you think about networking, for the most part, you want to really have a network that can support your application development. When we have to think too much about our network, it's kind of not working the way it should. We want to think about it, come up with a great topology for our network, and then really just make sure we don't have to worry about it too much after that, and that it supports what we want to be able to build. So I structured the talk around world-class network performance and capabilities, and we'll be diving into a few areas. And the first one I wanted to dive into was the scale, availability, and performance, and talk about a few areas in that space. The first one, and you may have seen some of these slides if you went to Peter DeSantis' talk last night, is around global infrastructure. Now, what are we running? How large is the AWS network? And again, if we look back, EC2 turned 10 in August last year, 2006. We launched in August 2006, so in 2016 we were 10 years old. And in the first 5 years of EC2, we launched 4 regions, and we were pretty happy with that. That was a good pace. 4 regions, right? We had the US East 1 region, we had US West 1, we had EU West 1, and then we had our region in Singapore. The next 5 years, we launched 7 regions, so we nearly doubled that. And those regions are visible there. Well, in the next 2 years, from 2016 to 2018, we're launching 11 regions. And that's effectively doubling what we did in the first 10 years, over 2 years in EC2. And we expect that growth to continue. So as we think about that, that's our global backbone. We haven't really spoken about this too much. We don't tend to speak about it too much. James Hamilton gave a talk on it last year. But Amazon has been building, AWS has been building a global backbone, a global infrastructure that literally spans the globe. We're at the place today where all traffic between our regions, from our CloudFront POPs, over Direct Connect, our Direct Connect locations, with the exception of the 2 regions in China, all travels on fiber owned by AWS. And that's fiber that we can take care of. It's all 100 gigabit, and obviously not just a single strand, multiple strands of 100 gigabit to be able to handle that load. And the other thing is, one of my network engineers was commenting the other day saying, we really love the packets that are on our network, right? Those packets are very dear to us. We're going to make sure we look after them and get them where they want to go. Often, if it's just another provider out there, they don't love the packets as much as we do, right? Because they are packets coming to our network. So being able to extend our network out globally in the way we've been able to do, just at our scale, we can do that, really provides a network that gives you much better performance, lower packet loss, much better latency. The other thing I wanted to talk about, because there's a growing sort of discussion that I've heard out there about, well, I really want a global network. I want to build an application that is global. And in the very early days of EC2, we're going back to 2008, first half of 2008, we had similar discussions. This was before we had launched our first region. We had just had the US East 1 region, and we were thinking, how do we build this global cloud? And something we realized about the middle of 2008 was that we really need to, one, introduce the concept of availability zones. So this is 10 years ago. And two, make sure that our regions are completely isolated. And I thought I'd spend some time talking about that, because one thing we've learned is when you don't have isolation between your availability zones or between your regions, you're going to have an outage that could potentially span globally. So even though you think you've got, you're in multiple regions, you're safe, no region's going to fail for the same reason at the same time, if you're sharing any data between those regions, there's a good chance that you could actually have a global outage. So the view that AWS takes, which is quite different from what we've seen from the rest of the market, is that we want this strong isolation and to provide you with tools such as Route 53, CloudFront, and other services that can layer on top of this layer of very strong isolation to give you the global network that you need. So I thought I'd talk about, well, another saying we really like is, we've learned a lot in the last 10 years. We've learned a lot about how to run an isolated network and how to run in availability zones. And this is kind of a cool, geeky saying, there's no compression algorithm for experience. So let's look at some of the things we do internally to make sure we have strong isolation within our network and in our software design. The first one is part of our DNA. It's kind of core tenet of any system we're designing. If you worked at AWS and you were tasked with building our next service, one of the first questions you're going to be asked by a principal engineer or whoever leader's coming along and doing a review of your stack is, how are you making sure that you have strong isolation between availability zones? And you're not sharing data or sending packets across AZs. And you've got to come up with an architecture that does that. The second thing is we constantly think about blast radius. And blast radius really means if, or more case, when something fails, whatever it might be, a machine that fails, an unexpected network event, a natural disaster, how do we make sure that as small as possible number of customers or instances or network routers get affected? And this is something we constantly look at all the time, right? Because as we scale, we get larger. One thing we've been doing recently is introduce the concept of cells within our availability zone. Some of our availability zones now have hundreds of thousands of machines in them. That's a pretty big blast radius. So internally, we're actually running very small cells that are now completely isolated. The third thing is stage deployments. One of our SVPs has this saying, he says, the power to touch is the power to destroy. And really what he's getting at is if you can touch something in multiple zones at the same time or in multiple regions, well, you can break multiple zones and multiple regions at the same time. So if you're deploying software in AWS, you will be making sure that your software is staged on a certain day of the week, it'll go to one availability zone. And everybody will go to that zone. It'll be staged to a small percentage of that zone. If there's any problem, it's automatically detected and rolled back. But we'll never, ever, even if it's a configuration change, right? Sometimes have an engineer come along and says, just a configuration change. We should just push this one out. What's the worst that could happen? We have a long list of what's the worst that could happen stories for that question. So we're super paranoid when it comes to our deployments. And then the one I really like is we have active monitoring. So we actually have a system that was built by one of our networking teams that watches our network all the time. And if they catch a team sharing data between regions that they shouldn't be sharing, that team will get a page. Immediately, they'll be told, hang on a second, you've just deployed a system that's sharing data and breaking isolation. So I thought it was just interesting to give you some visibility. And the reason, we've just added another 9 to our SLA. So now we have 4 nines, 99.99, for our EC2 SLA. And it's this level of investment and paranoia and our strong isolation and the way that we build our architecture and our network that allows us to do that. Next area I want to talk about is instance performance. So we've done a lot of investment in this area. And if we go back again and look at how what we've achieved in this area over the years, C1 was launched in April of 2008. It was our first instance type. At the same time, we had to name our first instance. Before that, we didn't need to name instances. We just had one of them. And that's when M1 small became M1 small, and C1 became the C1 instance type. C1 gave you 1 gigabit per second of bandwidth. And we didn't even bother telling you what the latency was. The CC1 came out about 2 years later, and that supported 10 gigabits. Big improvement, but it still had latency in the tens of milliseconds. C3, and if you went to Peter DeSantis' talk, you heard a little bit about our Nitro system. C3 was the first time that we actually offloaded the network processing off the x86 processor and onto dedicated hardware that ran on the box. And you can see the improvement we saw there. Enhanced networking, packets per second of more than 2 million packets per second, and latencies now of less than 100 microseconds. So big improvement. C4 saw us use the same hardware for networking, but we used EBS. We actually offloaded EBS into another storage card. So now your EBS had similar sort of performance. Big improvement in IOPS. And then C5, which just launched, is a whole new system. And this is really the system now where 100% of all processing, whether it's the hypervisor, the network, the EBS volume, the local disks, whatever it is, actually runs on offload cards. And we can give our customers 100% of that x86 processor, or those x86 processors that are in that box. And you can see the network performance is now down to less than 50 microseconds. And when I tell most customers 50 microseconds, none of them are too worried about that. They can build applications that don't really notice that sort of latency between instances. The other thing is 25 gigabits per second, so just constant innovation. And if you could see the roadmap where that arrow is going, which I unfortunately can't show you, there's hopefully going to be good news in the years to come. The next thing we want to talk about is instance bandwidth limits. So we've got performance on the instance, but what about limits between instances? Well, today, within a placement group, you can get 25 gigs per second. Within a region, you can get 5 gigabits per second between instances. To S3, you can get 5 gigabits per second. And to any other source, whether it's the internet or direct connect, you can get 5 gigabits per second. Wouldn't it be great if we could increase a few of those numbers? With the click of a button, we can go 25 gigabits, and that's coming out next week within the region. So whether you're in a placement group or outside of a placement group, as long as it's in a region between availability zones, you can get up to 25 gigabits per second from our largest instance types. The other one is to S3. So 25 gigabits per second to S3 within the region. So if any of you have data processing workloads that need a lot of bandwidth from S3, this hopefully is very good news. I want to talk very briefly about Hyperplane. A couple of years ago, 2014, the Elastic File System team approached us, and they had this interesting requirement for a load balancer. They said they needed to put a private IP address in the customer's VPC to allow them to attach an NFS mount to that VPC. And so we started building a system called Hyperplane. And Hyperplane, we now call it a network function virtualization system, but it's essentially a fault-tolerant distributed system that powers most of our high-performance, highest throughput, highest availability networking features. And we're super proud about this, and you're going to see us talk a lot more about this. Hopefully, going to be publishing a paper about it in the coming months so you can get more detail. There's also a talk, which I'll talk about shortly, that Colm's giving about Hyperplane. But it underpins NAT Gateway. So when you saw NAT Gateway launch, it was a service called Hyperplane behind the scenes that's running that. It also underpins Elastic File System, as I said. And then most recently, it underpins the network load balancer. One of the super important things about Hyperplane is it's actually built on EC2 in the same way that any of you would build a service. So we're actually running Hyperplane on EC2 instances in a cluster formation using a whole lot of distributed system constructs. But we're just a customer of EC2. And because of the improvements that EC2 has had on the underlying network, we can get that same 50 microseconds performance and other benefits from Hyperplane. So with that, I want to just call out Colm McCarthy's talk later this week. If you're interested in a really deep dive into Hyperplane and what that looks like, I'd recommend attending the NET205 talk on Friday, if any of you are still around. So let's talk about Network Load Balancer. This came out in September, again, powered by Hyperplane. Super excited about what we managed to achieve here. TCP-based, it does 1 million plus requests per second. That is a lot of requests per second. There's very few applications that need that. We actually ran our first load test, or one of the first load tests with Network Load Balancer. And out the box, it started off at 1.5 million requests per second. And we just kept ramping up our test stack, and eventually the back-end instances on our web stack fell over. So we added more back-end instances, and we were at about 3 million requests per second, and we just kept sending more transactions, and the network load balancer was absolutely fine. And when the application stack fell over again, well, that's where we ended the test at about 3.5 to 4 million requests per second. So it's a pretty amazing load balancer with 50 microseconds of latency. But it also gives you a 25% reduction in cost. So this is really for your high throughput use case. Available in all regions and has the same compliance, not just HIPAA, but other ones as well, that what ELB has today. Let me just go back. Some of the other features, it has a static IP address. If any of you have used ELB in the past, you know that at times the load balancer IPs can change. And with Network Load Balancer, you can actually give it an elastic IP and say, I'd like that IP address to be bound to the load balancer and never change. It preserves the source IP, so it's completely transparent. Your backend instance is actually going to see the IP address of the client. You're not going to see the load balancer at all. So there's no need for proxy protocol or anything like that with TCP. It feels like the client just spoke directly to your backend instance. It supports long-lived TCP connections. With Elastic File System, those connections live for years. And Hyperplane and Network Load Balancer can actually support that. There's no case where Amazon will ever terminate a connection. If we have a hardware failure on the Network Load Balancer or Hyperplane stack, we've distributed the network state in the connection state in such a way that that connection can just shift off onto another box. So these connections just live, unless you terminate them from your back end, they'll stay up. And then no pre-warming required. And this is something, you've seen us, ELB needs pre-warming. Reality is a lot of customers, vast majority of customers don't need pre-warming. With NLB, it's not even an option. You can't even call us and ask us to pre-warm it. It just does millions and millions of requests per second. It's built into the framework. So I wanted to talk about a customer use case here. This is Beeswax. And Beeswax is an ad tech company. They're actually building a platform that other ad tech bidders are building on top of. And what the architecture basically looks like is you have a whole lot of ad exchanges. When you view a website, an ad exchange will literally go out to a whole lot of ad providers and ask them to bid, would they like to show an ad to the viewer of this web page? And it's a super interesting space because you only have about 20 to 30 milliseconds to actually say yes and make a decision. And you're literally going to spend money on that ad. So you've got to make a decision, do I want to spend my budget on this ad for that individual that's going to view it? And Beeswax moved onto Network Load Balancer. And some of the things they called out that they just loved about it, the first was low latency. Obviously, not taking up any of that 30 milliseconds that they have to respond to customers is awesome for their business. The second thing was resilient to spikes. There are times where these ad agencies will go offline, these ad exchanges will go offline, and when they come back on, they just flood you with requests that they've been queuing up. And with Network Load Balancer, that's just not a problem at all. You don't have any problem handling that. The third thing is completely transparent. They loved the fact that they could actually see who was talking to them, and they didn't have to deal with the load balancer in between. And then finally, the static IP address just made a whole lot simpler to configure and not have to worry about, because often ad exchanges will configure firewalls and use A records and that sort of thing to call you. And that's not a problem. So that's Network Load Balancer, super performant. Highly recommend you look at using it. It is 25% cheaper than Application Load Balancer on bandwidth. Let's talk a little bit about CloudFront. So CloudFront is our CDN or content distribution network. Global, it has 107 edge locations today. This team has just been adding edge locations. I saw a press release about 5 weeks ago that said we just crossed 100. And they're already at 107 about 3 weeks later. So there's just a crazy rate of expansion that's been happening. They also provide you with security at the edge. So whether it's SNI or you want to do SSL termination right at the edge closest to your customer, really improves latency. CloudFront can do that, and obviously high performance as well. If we look at the CloudFront POPs, there you can see the 107 CloudFront POPs located around the world. And then obviously you've got the Amazon backbone. So every CloudFront POP is connected to the Amazon backbone. So you're getting that level of performance. It's coming on a network that we own and we can tune. So in the last year, they've launched 39 new edge locations to get to that 107. They've also given you the ability to configure some timeouts. They've added improved security policies and HIPAA compliance. One of the more interesting things that they've done is they've also added Lambda at the edge. So they said, well, there's a lot of compute that we could do out of a CloudFront POP. to not have to bring that traffic back into a region and save that latency and give our customers really great experience. And this was launched this year, and they've already launched 3 additional features: query string parameters, advanced response generation, and content-based origin selection. And the customer use cases here are really interesting. A lot of customers are now using Lambda to implement part of their legacy APIs in CloudFront, and basically doing turnarounds or redirects, they're doing authentication. There's just an endless number of ideas that customers are coming up with. So certainly something worthwhile taking a look at. So, at the end of the performance section, I'd like to welcome Olga Hall, who's the Senior Manager of Technical Programs for the Amazon Instant Video Service. And she's going to talk to you about what it took to run the Thursday night football on Amazon Instant Video. Please welcome Olga.
Appreciate it. Video, I've been with Amazon for about 7 years, and I own Amazon Video Availability, which basically means that when our customers click play button, video must play without fail. I love my job. I absolutely love my job, because as part of my job, I get to work with partners and Amazon engineering teams where we have to, and we are pleased and excited to launch such things as Thursday Night Football. I have a feeling that at this point of reInvent, all of you have heard about NFL stats and Thursday Night Football, all right? And I also have a feeling that there's a lot of fans here. So a lot of you probably heard about Prime Video right now bringing you Thursday Night Football. So what I would like to do is share some lessons learned and some strategies about partnering with AWS and what worked for us. So let's take a look at who we are as a service. First and foremost, we're a subscription service. You know us as someone who brings a video as part of your Prime Video subscription, and then depending where you are, in which country you are, you can sign up directly for Prime Video. As part of Amazon Prime, we have originals, and we get to bring you such content as Grand Tour, My Favorite Transparent, A Mozart in the Jungle, and I hope you get to watch it as well. Along with that, we're also a transaction service. You can buy or rent. And along with that, we're also giving you option to subscribe to channels, such as HBO. In essence, we're very flexible. And that means that we need to support our existing customers, and we need to think about new customers and how they interact with the content and how do they enjoy the content. Our first really large-scale experience with launching a very large-scale Amazon original was Grand Tour last year. Why? Well, first of all, the predecessor for Grand Show had a built-in audience of 350 million users, 350 million customers who loved it, okay? And we needed to think hard about architecture and choices that we make to bring this show to our customers. So what happened? In 2016, we were in 4 countries: UK, Germany, Japan, US. We launched it in November. And then very shortly after, we were in 242 territories, bringing this show with us globally. And we get to learn a lot about customer experience and seasonal patterns and how customers engage with the content. Things change. You probably have heard that in 2017, we got into sports, and we realized that live events are completely different. It's not video on demand. And we had to learn about customers' behavior and personality all over again. How do we do that? And this is where our rich portfolio of how we launch really helps. Why? Because we get to do things like bringing you Game of Thrones. This is what I call Winter in July. Game of Thrones was pretty cool for a number of reasons. So if you're thinking about launching a really large-scale event, having a strategy where you are preparing part of your stack, and you're basically stress testing and also focusing on the performance and preparation along the way, having that strategy helps a lot. And we learned a lot with Game of Thrones because we had it as a live stream and also video on demand. So let's take a look at what's really interesting about it. Dave, in his previous section, mentioned an idiom that holds true. We've learned something that a very old saying is really, really true, which is last minute is truly last minute. What you see here is customers subscribing. And that spike is literally a minute before the show starts when we see customers subscribing to Prime and also to HBO. This was the moment in time when we realized that last minute it's just not a saying. Spikes are not a saying, they're real. The reason I'm emphasizing this point, because many of you in infrastructure sector and thinking about large-scale events, we all talk about hockey sticks, for example, right? This is what I call Eiffel Tower, not a hockey stick. I call it Eiffel Tower on purpose so that we in technology have something different that is not a metaphor from sports. So here you go. And that was, for us, a really big realization. Okay, so we had to think through early enough, what do we do with our architecture? What do we do through our entire stack? There was a second realization that hit us. And that realization was that there is really no second chances in live TV. Imagine if you're watching a Jon Snow story that is about to unveil and we get to find out who he is, and the video starts buffering. That's horrible for those of you who are fans of the show. For those of you who are fans of Thursday Night Football, imagine buffering and delays when somebody is probably, your neighbors are yelling out and shouting for what's happening. That hit us. We have to really think hard about choices, about architecture dependencies, what we do. So let me tell you what we've done. First and foremost, we think through such things as scaling of our services. And when I say scaling of our services, that includes everything, the entire stack. I talked about us preparing live infrastructure. We also thought through our existing current services and our dependencies, the components that we run on. Scaling in the context doesn't necessarily mean that this is just load testing. It also means that we partnered with CloudFront. We thought through the strategy of bringing content and caching content on CloudFront close to other customers, and then we used AWS regions for origins. And we continue to understand customer behavior throughout the season and throughout the work that we were doing during that time. So let me see what the statistics are. The first game that went through on September 29 was watched in 191 countries. 191 countries, apologies. 2 million people tuned in to watch the show. That's amazing. I was really excited. We were really excited about this. And on average, the average viewer tuned in for 55 minutes. And that's significant. Because if you think about your own experience of watching a TV or a game, you probably walk out, you do something else, and you kind of zoom in and out, so to speak, right? 55 minutes for a football game. It is pretty amazing, and it has implications that we will talk about. All right, let's see what else is interesting. Countries. Customers enjoy the show in the United States the most. I mean, that was the biggest audience. Mexico, Germany, no surprises there, right? I see some nods in the audience. States. Here you go. California, Texas, New York. It was interesting to see correlation in 2016. We noticed that Dallas Cowboys drove the most attention and the biggest audience, and that explains that Texas basically has biggest viewership. Little known fact, we also have alternative commentary for the games, and UK narrative for the games is amazing. It's pretty funny, and it's highly enjoyed by our customers. 2 million active viewers. What I would like to point out here that earlier this week, we announced launch of Media Tailor, which is server-side ad insertion. And with Media Tailor, what it allowed us to do, deliver seamless streams to our customers and personalized streams to our customers. That means for those of you who are thinking, hey, 2 million, you may apply some caching strategy. Look, a personalized streams, caching strategy will not work. And we had to do something different. So let's take a look what we, basically a little bit later, what we've done. Another statistics that is highly interesting, during the game, our load balancers were processing and transferring about 58 terabytes of data. That's amazing. And another piece of data that we're really excited about, that during the game we managed about 176 million connections seamlessly. That's also amazing. So what worked well? What helped us to prepare? Obviously, as many of you, we forecast the peak load and we basically prepare the plan. How do we execute for this peak load? We thought through that we want to automate our stress testing. We call stress testing and load testing game days. So we automated our game days. And we run them right now regularly, 3 times a week, Tuesday, Wednesday, Thursday. One thing that is probably different for Amazon Video, we run these game days in production. And we run them for a fairly long time. Specifically for TNF, we knew that the run for the game could be up to 4 hours. So one of our game days was 4 hours and a little bit more. And during this game, just another interesting data point, one of the TPS that we put a load on the service was 3 million TPS. That's pretty cool. And it's across all of the regions. This is specifically for the services where caching wouldn't be necessarily the strategy that we wanted to implement. And then the last strategy that I want to highlight, what really helps in this case, is moving the bits, the decisions, much closer to the customer and moving content closer to the customer, where all of the stack and new technologies that Dave talked about really helps here. That's amazing. So what's next? Well, the new normal for us is the fact that we are getting into sports events. We're getting into music, and supporting the sports events are absolutely new normal. For the next 4 years, we announced our partnership with tennis, and we're really pleased and happy to bring you about 37 events that will be happening as part of the partnership with ATP. Because Christmas is coming, I'm really compelled to tell you that one of the other things that I'm personally excited about, bringing you a short movie from Mariah Carey, All I Want for Christmas Is You. Little known fact, but ever since the song launched in 1994, about 14 million copies of the song has been sold. And if you look at the last year, it remained #1 song during the holiday period for quite a few weeks in a row. So what we're doing different this year, we're partnered with Mariah Carey, and there will be a short animated movie. I hope you get to enjoy it. I hope your kids get to enjoy it, and it will be available in time for Christmas. Thank you.
Thanks, Olga. It was really quite terrifying working with the team, taking them live with that sort of scale. I find, every time I get involved in one of these live streaming services, I just can't watch it anymore. Because you just kind of like you're on edge all the time, right? So it does take the joy out of it. But it's really amazing what that team's done to scale that service. So let's look very quickly at some of the network and security compliance. Something we've really focused on in AWS over the years is just our security posture. Back in the day, we used to hear customers say, "Oh, I don't want to run in the cloud because it's less secure." Well, not less secure, but I'm worried about security. What we see now is just the abundance of security tools, automation, services, compliance. We see customers like Capital One literally saying that they're more secure in the public cloud than they could actually do in their own data center. And that's been an enormous change for us and something we're very, very proud of, and just something we really focused on all the time. So a brief look at some of the security services we have. So virtual private cloud, obviously it's a private network, provides a number of security services. Obviously security groups and ACLs, everybody knows what those are, you can use to control. NAT gateway, really being able to have a private cloud that gives you, without an internet gateway, you can talk out to the internet, it's a managed NAT gateway. That service launched in 2016, 2015, and it's been incredibly popular. And then the other one is obviously flow logs. And we're seeing customers do incredibly interesting things with flow logs. A lot of customers are actually using them as they set up their security groups and ACLs and all of their security, and then they monitor flow logs. And they actually have this feedback loop where they can go back and then change the security groups and ACLs based on the traffic that they've observed in flow logs. So they've built a lot of systems around that. Super interesting to sort of lock down an application team to really only the endpoints that they need. Obviously, we have VPC endpoints for Amazon S3 and DynamoDB, which have been around for a while. And then we announced Private Link for AWS services. Now, Private Link is available for these services today: Amazon EC2, Elastic Load Balancing, Amazon Kinesis, EC2 Systems Manager, and AWS Service Catalog. Private Link's a little different from AWS endpoints that you may know from S3 and DynamoDB. And one of the reasons is that you actually take, with Private Link, you actually have a private IP address inside your VPC when you talk to that private IP, you actually hit the service. So here's an example of Kinesis. And what I've done here is I'm actually showing you the Kinesis VPC. So that VPC is owned by the Kinesis team, and that's where they're running their service on EC2. And what they do is they put a network load balancer in front of their service, and they then share a private IP address into the VPC of any customer that wants to use Kinesis inside their VPC. So you really are getting private connectivity, secure connectivity from a private IP address inside your private network to whatever AWS service you need. And so we're super excited about this. We've had a lot of great feedback. It's also available over Direct Connect. So with this, I could now use Kinesis from within my own private data center. I can use Kinesis within my CIDR range, within my own data center, without actually going onto the internet. So that network is, their endpoint's completely private within my VPC. The other security services we have, website application firewall, that's integrated with ALB today, as well as application gateway and a number of other services. AWS Shield, two things there. We have Shield Standard and Shield Advanced. Shield Standard, everybody gets. We've had it for years and years and years. We just told everybody about it last year. Shield Advanced came out, and Shield Advanced is just an amazing service. Signing up for Shield Advanced, you get access literally to the DDoS team within Amazon. If you're going to expect any sort of DDoS, or you've had any sort of threat for a DDoS, that team will work with you to make sure that we mitigate that. And then Certificate Manager as well. We've never had this problem at Amazon, but I've heard some customers have it where a certificate expires and actually affects their application. Anybody ever? I promise you, we've never ever had one of those that I can recall. But Certificate Manager, I'm really hoping just ends that, because they've just released a thing where they can actually do certificate renewal based on DNS, so you no longer have to respond to the email that they send you. And now hopefully I can put a certificate on my load balancer and just forget about it. And every year it's just going to be renewed and kept up to date for me. So I think that's awesome. That's something we really need to get, And then obviously we have a number of marketplace partners. So we really partner with a lot of companies in the AWS marketplace and elsewhere. And a lot of these companies are pushing to run their services on AWS and inside your VPC. So if you're running something on-prem, Palo Alto, Cisco, whatever it might be, there's almost certainly one available in AWS that you can run inside your network and get that same level of security that you want. So that was a brief. Let's look at easy to use and broad feature set. And yeah, we want to start off with a few things in VPC that we've launched over the last year, just a refresher. One of them was resize VPC. Apparently, a couple of customers create a VPC and they think they'll never ever need more IPs than what they put in their VPC. And then at some point they need more IPs. And we launched Resize VPC, which allows you to add contiguous slider blocks. The other one is security group rule descriptions. My vote is that this is probably the largest feature that we've launched this year. The ability to label your security group rule description so you know why you added it there. So customers have been very, very happy with that one. Apparently, customers don't remember CIDRs too well. And then default VPC. So this was interesting, because just to give you an idea of how we work with customers, so many of you will call dev support. We meet with dev support each week, and we say, what are customers asking for? What's your number one feature? And default VPC was one of the number one features for the telephone API. Customers were calling dev support and saying, please make this VPC the default VPC, and dev support could hit a button and call an internal API for you. And now you can do that via the API, so it's another great feature for setting up the default VPC. And then another one that we launched, apparently sometimes customers release the wrong EIP. So, and then if that's a frantic call to dev support again to see if they can help you, you just gave up an IP address that is pretty important for your business, that you baked into some software that's now on a device you can't change. And we actually launched EIP recovery, where you can just call allocate address with the EIP and you'll get it back, as long as you do it fast enough. And to tell you that the EIPs don't get recycled very quickly. We tend not to like hand an EIP out to another customer immediately because sometimes traffic goes with it. So they normally bake for a number of days. So as long as you realize pretty quickly, you should be good. And that's been a very popular feature. I wanted to talk about application load balancer. We spoke about network load balancer. Very quickly, some of the things on application load balancer. And while network load balancer is all about performance and low latency and transparency, application load balancer is all about features and layer 7. And we launched with a couple of features. It came out about a year ago now. So HTTPS layer 7. It has advanced routing. And last time reInvent, I think we had just launched it, and everybody was saying, when are you going to add more than path-based routing? And we've done a number of the routing additions over the years, so hopefully you've seen it get a lot richer. We also support containers. So whether you're using ECS or you're using other container services, really the secret here is that it does dynamic port allocation. So you can register the same EC2 instance with multiple ports behind a single ALB, and it allows you to really get a lot of utilization out of a single instance. And then supports things like WebSockets and HTTP2 and those sorts of things, as well as advanced web protocols. Really a lot of innovation this year. Host-based routing, the ability to host on host multiple websites with host names as part of the DNS name on a single load balancer. And then multiple certificates. Anybody see this one come out? Multiple certificates, SNI support. So thanks to the SSL v3 vulnerability a few years ago, we're seeing the vast majority of browsers supporting SNI now. And so that's something that you can quite safely do if you have browsers. A little less safe if you've got APIs, but certainly in the browser space for websites, SNI is a great feature. And then blue-green deployments as well with code deploy. So really trying to solve that problem of how do I safely deploy to a load balancer. And another customer use case here is Edmunds. So Edmunds is a car company, and they ran a container stack, and that's what the application looked like. They were running a lot of classic load balancers, which I thought was a great idea. But anyway, they said, well, can't we do anything to collapse those? So when we introduced host-based routing on ALB, and we introduced SNI, this is what their stack did. So they're now able to host literally hundreds of websites on a single application load balancer. So that saves them a lot of money. Certainly on the hour, and that's all now being routed through to the containers. And that's exactly what they said. So they said, looking to save significant infrastructure costs as a result of migrating from classic load balancer to application load balancer and doing the consolidation. So it's something you may want to think about if you have stacks where you think you could maybe consolidate by moving to application load balancer. We certainly are supporting that. I think it's a good thing to do. You just want to think about the blast radius. Don't put everything behind one application load balancer for an entire company. So just think about what makes sense there, but certainly a good way to save money. We've seen some customers save up to 90% cost reduction by doing consolidation across their load balancers. So it can be a significant amount. So that's application load balancer. The other service we had, anybody know Amazon Lightsail? We launched Amazon Lightsail about a year ago, really as a sort of entry-level offering for EC2. A lot of AWS has become pretty complicated for the new user, and they really want sort of like a host-based experience, and Lightsail does that. And we're super excited. Literally, I think it was announced about an hour ago that there's now a Lightsail load balancer. So if any of you are using Lightsail, you can get a load balancer for $18 a month, no additional charges. And then the other one is, this is more obviously a developer-type feature, is the time sync service. So we're launching this at reInvent as well, which gives you a synchronized, very, very accurate atomic clock, basically, inside your VPC, so NTP, that you can basically use for all of your instances. And we're down to about 1 millisecond of accuracy. One of the words I love in this space, which I've learned recently, is you have to discipline the clocks. So we discipline our clocks all the time, and they're very, very accurate. So it's an interesting term to use there. And then let's talk about driving innovation. This is the section I'm really most excited about. One of the things I've been trying to push with the team, and as we think about our vision, is I want the network's got to support rapid innovation. You just got to look at the number of applications we have on our phones today, and the number of new websites coming out. It's just the pace of innovation we're seeing that I really believe the cloud has been enabling, and hopefully you're seeing this in your own organization as well. It's just astounding, and I want the network to support that, not slow it down. The model that I think we're very familiar with is, as an application developer, I build something, and I want to take it live. I have to go and speak to the firewall team. And I've got to wait a few days for them to open up a firewall rule, and then I've got to go and convince the load balancer team to please give me a load balancer. And that just slows us down. We want a network that supports our infrastructure. And when we launched VPC back in 2009, we didn't think anybody would need more than one VPC. And so that's why we gave you guys one VPC. The limit was one. Who would need more than one network? It didn't make any sense at the time. Turns out that customers actually, some of them have thousands of VPCs. They found good reasons and great architectures. And the feature you have today for joining VPCs is called peering. And so you can peer VPCs together. We launched that a number of years ago. It's been very popular with our customers. There are a few challenges with this, though. The first one is overlapping IP addresses. You can't peer two VPCs together if the IP address ranges overlap. And that becomes pretty challenging, managing those IPs and remembering which team you gave IPs to. And you have to go buy service. There's literally a whole business, a line of business called IP management systems. And we really shouldn't need those. The second one is controlling access levels. So the one VPC has access to everything in the other VPC, and sometimes you don't want that, right? You want something that's a little bit more constrained. It might be that you're sharing networks between two companies, and I don't want to share their entire network. So some of you may have seen this yesterday on Tuesday morning. This was announced during Terry Wise's keynote. We've taken that private link technology that I spoke about for application services, and we're giving it to you to use for your own applications. This one is huge, by the way. So let's work through a few use cases here. So private link is powered by network load balancer, so you have to put a network load balancer in front of your application to use private link. It provides you with a secure endpoint within your VPC. It's also integrated with application marketplace, and that list of customers at the bottom of the slide, those are marketplace vendors that support private link today. So for example, if you want a Snowflake database that is privately located within your VPC that you can access with a private IP or use over direct connect from your on-prem database, Snowflake have integrated with us to give you that possibility. Snowflake took network load balancer and put it in front of their stack, and they can now provision an IP address in your VPC that your network team is happy with because that's within the security perimeter of your VPC. It's one of your IPs that appears. So let's look at what this looks like, right? So we have a VPC that doesn't have a NAT gateway. It's just going to use private link. So the first thing I might want to do is I want to use Amazon Kinesis. So I can use Kinesis. I don't need a NAT gateway. Don't need an internet gateway. The second thing, maybe there's a team inside my organization that wants to build an application, a login service. Well, they go and build that. I don't have to worry about what CIDR I give them. Actually, I can give everybody the same CIDR now. And at some point, they say, OK, we're ready to go live. Well, I just make one API call, and we agree on the endpoint, and I have their private endpoint inside my VPC. And I can share that endpoint with thousands of VPCs. So now you can just create this sort of service-oriented or microservice-style architecture. The other thing is maybe you want to use Snowflake or some other third-party provider. Well, Snowflake's available. You can put a private link endpoint in that VPC. And maybe you want all of this integrated with your on-prem network. Well, it all works over Direct Connect as well. So I think if you think about your network architecture today, where you've got multiple peered VPCs and you're battling with a whole lot of things, private link is a really, really interesting thing to consider using. Really, I think it's going to drive a lot of innovation. You can start just handing out CIDR ranges to teams, give them a CloudFront template that creates a network. I'm super excited to see what it does to your topology. I'd like to welcome Jesper Jorgensen, who's a VP of Product Management at Salesforce Heroku, to let you know what Heroku is going to be doing with private link. Thanks.
Thanks, Dave. Thanks for having me up here. My name is Jesper Jorgensen. I'm in product management at Salesforce. I've been with Salesforce for 9 years, working on a bunch of different products there, but spending a lot of time on Salesforce Heroku. Salesforce Heroku is a service that we've been building on Amazon since day one on Amazon Web Services from 2008 and forward. So we've really been part of the journey that Dave has described here of the fewer features in the beginning and more features now, and we've gradually taken advantage of them. Our customers use Heroku to build custom experiences for their customers. And Heroku has been uniquely designed from day one to be a platform that lets the developers just focus on that customer experience and nothing else. So more than anything, that means developers definitely don't want to deal with networks. And that's been our mission all along, to continue to expand the power of Heroku without introducing any complexity. That's hard because to build really cool applications for their customers, developers want to take advantage of a bunch of things. They want to take advantage of microservices. They want to compose. They want to bring in data stores like Postgres databases, Mongo databases. They want to log to various log management services and so on. So underneath the covers somewhere, there needs to be a network that ties all this stuff together. And Heroku has dealt with that for a while now through a really innovative mechanism called our add-on provider ecosystem, where we work with third parties to build integrations around how services are provisioned and linked up to applications in a way that developers don't even notice. So if you want a Mongo database from MLab, for example, you type Heroku add-ons at Mongo, a little bit more than that, and then it's one command. You get a Mongo database, and the application is told where to find that Mongo database. It gets an IP address, and a port number, and credentials. And so the developer doesn't have to deal with that. But we just heard that that can be kind of tricky when we talk about network topologies, and they can really get in the way. How we've dealt with that up until now is by mostly using the public internet. So all those IP addresses, all those ways that these services were talking to each other went over the public internet. And clearly, I think most of you who sit here today know that that's not enough. That's not where we want to be. And so we've been on the journey with Dave and with Amazon Web Services and introduced a number of private networking features over time. A couple of years ago, we introduced Heroku Private Spaces that will let you run your applications inside a private network, which is powered underneath the covers by AWS VPC. And we recently introduced VPC peering. So you can take this world of rapid application development in a private space, in a private network, and link it to your VPCs running in AWS. And you can get the power of AWS services, everything that goes inside a VPC, and the power of the developer experience of Heroku. You get those combined. That's out today. But as Dave also talked about, you will eventually run into issues when you have to manage whole networks combined together. Suddenly, you have sitter block management interfere with how you're going to compose your applications. And that runs counter to keeping those concerns away from developers. So, and this is where Private Link comes into the picture. By taking advantage of Private Link to expose all these different services to the applications, we can remove that concern. Sitter blocks, IP range management is no longer something that that is related to how you compose your applications. We can work with partners, some of the partners that were up on the slide here just previously, to put a private IP address inside the private space where your Heroku application is running, and have that transparently actually route back to where the service is running, and that service can be managed by a third party to Salesforce, such as MLab or any of the many other companies out there. Some of you may be here in the audience today, and that can be completely transparent to developers. So we're really, really excited about where the AWS networking team is taking things, and again, I appreciate the opportunity to come up here and talk about it. Thank you, David.
Thanks, Jesper. So I'm super excited. As you think about Private Link, go read the documentation and really understand it, and think about your topology and what you could be doing with Private Link. I really do believe it's a game changer, and I think a lot of you, hopefully we have a conversation at some time, you tell me what you've done with Private Link. One more thing is sort of driving innovation. So we have this massive backbone. So traffic between regions today is traveling on the Amazon backbone. We spoke about that. Well, we still have a bit of a problem. It would be great if we had private connectivity between VPCs located in different AWS regions. Anybody would like that? I don't know if there's enough hands. Quite a few of you, it looks like. Well, I'm happy to announce available today is inter-region peering. Inter-region peering works very much like intra-region peering, but it allows you to securely connect 2 or more VPCs located in different regions together with a peered network. And so what this means is VPC in region 1, so I've got 2 VPCs there, and I want to connect those VPCs together. They're in different regions. Today, I would have to use the internet or a public IP to connect those VPCs. Well, I can now create a peered connection between them. A VPC in US East 1 can now talk privately to a VPC in EU West 1 across the Atlantic using the Amazon backbone, and all traffic is also encrypted. So connecting 2 VPCs together, highly available, no single point of failure. You're using all of the normal Amazon hardware. You're not having to run a VPN device or anything like that you may have done previously for this sort of thing. All traffic stays on the AWS backbone, and all traffic is encrypted as well. One of Colm's talks, we'll also be talking more about that encryption and how we do that. So that's inter-region peering. Super excited about that. And finally, I want to talk a little bit about seamlessly integrating on-premises networks. And as we've been working with customers, we've realized over the years that there's the migration phase, right? You've got a lot of stuff that you migrate, and you want to be able to migrate easily to AWS. There's also a phase where there's some stuff you're not going to migrate. You may have a mainframe, you may have something in your data center that you're not going to migrate to AWS right now. the one thing you're almost never going to migrate is your branch office, right? Or all the hardware and software that you have running in your corporate facilities. So we need to have a network that can support seamless connectivity between wherever you may be outside of the cloud and AWS. And a couple of services we have here that I want to mention. So VPN, obviously you all know what that is, and that service continues to innovate and release new features. Direct Connect, which we'll dive into more detail. And one of the features we launched on Elastic Load Balancing, which I think is really, really interesting, is about 3 months ago, Application Load Balancer and Network Load Balancer can now load balance to an IP address that's not an EC2 instance. And so you can set up an ELB, or Application Load Balancer or Network Load Balancer, and put an IP address of a machine that might be in your data center. And so we've seen a couple of really interesting use cases. Some customers are using that to migrate. There's even a few customers that tell me it's so difficult to get a load balancer inside their own data center that they just use ELB now. So they don't even bother asking their load balancing team for a load balancer, and they're quite happy with the latency over Direct Connect and back. It's just less painful. So certainly interesting use cases. So let's take a look at Direct Connect. Obviously, it's private connectivity, MPLS style. Consistent performance. Often the internet can give you inconsistent performance depending on the provider and time of day, whereas Direct Connect is a dedicated fiber connection into AWS. And also reduces the bandwidth costs, so it is significantly cheaper than using internet bandwidth. They've made incredible progress this year. Direct Connect team has launched 25 new locations. They literally just have a team that all they do is launch locations almost every single week. Global partners, 125 global partners. So that's where they're at now. And those global partners can get you connectivity into Direct Connect if there's not a location closest to where you are. Because literally this Direct Connect's about physical connectivity. There's literally a fiber from your data center into a Direct Connect location, and then you're on the Amazon backbone from that point. They've also done 100 gigabits through lag, so you can have 10 gigabit connections to get you to 100 gigs. And they've also provided things like bring your own ASN. I was super surprised at the numbers of customers that suddenly brought their own ASN. I didn't know so many people had ASNs, but it's been an incredibly popular feature. And then sort of launched in the last 4 weeks. You can see we've got Denver, Phoenix, Helsinki, Chennai, and Madrid. So just massive rollout. So we look at the Direct Connect locations all around the world. You can see we have 67 of them. We've launched a few in the last few weeks. And when you connect into a Direct Connect location, you have to find a location that is associated with the region that you're closest to, right? So originally, these direct locations were tied to US East 1 or tied to US West 1, whatever it might be. And essentially, you find those locations and then you run some fiber. We always typically recommend that you have 2 separate lines coming into 2 different locations. And one of the features I wanted to talk about at the end, which came out about a month ago, is DX Gateway or Direct Connect Gateway. And what Direct Connect Gateway does is it basically means that you can now find the closest location to where you are. So if you're on the west coast of the US and you want to connect to US East 1 on the east coast of the US, you no longer have to worry about getting fiber across the US to get there. You just go to the location that's closest to you or the partner location that's closest to you where you are. And with DX Gateway, you can basically get onto that backbone, Amazon backbone, from any location and get to any DX location. So it's really, really lowered the bar on being able to get into the Amazon backbone from anywhere in the world. And those POPs are being added. I mean, obviously, the 2 that I'm most excited about there are down in South Africa, Cape Town and Johannesburg. Super excited to see that. But just, richly within 50, 60 milliseconds from any location, we now have a DX location that you can connect into. So there have been a lot of announcements. We've covered a number of things. Hopefully, it was super useful. One of the things, as I started with, literally 90% of what we do and what's on our roadmap comes from you, the customer. We've been excited about a lot of the features we've been able to get out for reInvent this year. And the great things about customers is you guys are already thinking about the next thing that you need. And so keep that feedback coming. We're certainly not going to slow down at all. One of the sayings we have at Amazon is it's always day one. And we literally believe that. Like 10 years in, the cloud is just beginning. And my roadmap runs out 4 or 5 years of things we would like to do, and we literally can't get there fast enough. So it's been great speaking to you. Hopefully it was useful. Thank you for your time.